Complete and balance the following redox equation. What is the coefficient of water when the equation is balanced using the set of smallest whole number coefficients? Our first step is to assign oxidation numbers to our elements. So in permanganate, we have an overall charge of -1, and oxygen always has a charge of -2. So our overall charge of oxygen in this is -8, which makes our manganate +7. In sulfide, oxygen always has a -2, and we have an overall charge of 2-. So the charge of sulfur is +4. On this side, we have a charge of 2+, so our oxidation number is 2 positive. And the same deal with oxygen, we end up having a charge of -8, which leaves sulfur with a charge of +6. So now that we have our oxidation numbers, we deduce which one is reducing and which one is oxidating. So manganate gain 5 electrons, and sulfur lost 2 electrons. So let's start with our half reactions. Let's start with sulfide to sulfate. So we have SO3 with a charge of 2-, and SO4 with a charge of 2+. And this is our oxidation. So now we start balancing our components, and we have an extra oxygen on this side, so we have water to this side to balance it out. So we have 1 water. Now that our oxygens are balanced, we have to balance our hydrogens. So we add 2 hydrogens on this side. Now that all of our components are balanced, we add the electrons. Since we lost 2 electrons, they are placed on this side of the equation. Now that we're done with this half reaction, we go into our reduction. Notice on this side we have oxygens, and on this side we don't. So we add water to that side. We have 4 waters. And on this side, to balance out our hydrogens, we add 8 hydrogens. Now that our components are balanced, we add the electrons. And since we gain 5 electrons, we add them on this side. Now that our reactions are balanced, we have to make sure that our electrons are the same quantity. So we multiply this equation times 5 and this equation times 2, which makes our half reactions look like this. So now that we have both of our electrons the same quantity, we just add the whole equation and cancel out stuff. So we cancel out our electrons and our waters and our hydrogens. So our overall reaction ends up looking now that we have all of our overall reaction, we look for the coefficient of water, which is what our question was asking us, and it's a 3. There's no way we can reduce 3 or any of the other numbers in our equation by the same number, so our answer is 3.